Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
Okay, let's get started, guys. Okay, so first of all, before going anywhere with the deployment part, you need to understand something about machine learning pipeline in different software and the web backend design paradigms. Okay, so now what has happened is you have learned some a small bit of Python, and now you have understood some basics of stats and been able to do some EDA and maybe build a couple of machine learning models utilizing some data that was provided to you. Now, so far, this is very standalone kind of work. Why I'm telling you standalone? Because in real world, software development is pretty complex. Okay, there are a lot of moving parts that are available, and accordingly, one needs to develop their machine learning or alter their machine learning pipeline as well, so that it can fit in with the software development or the web development paradigm. Okay, so unless we don't do that, we are not gonna get the results, or we are not going to get the exact optimization of the software that we are working with actually. So the idea is, okay, let me ask you first this question actually. How many people are already working in software field, like they have been programmers or developers at some point of time in life, or are currently also doing that? So you can just reply in the chat. Just wanted to get a idea like how many people are already working in this field. So how many people have either developed some kind of application, web backend, or end to end? Sorry, guys. Yeah, Parshuram. Hello.
Yeah.
so,
Hi.
so exactly, may I know like what is your experience so far?
So I have 10 plus working on the software side, like I
Hmm.
develop and yeah. So on the development side, yeah.
Okay, may I know like which language or which kind of paradigm you were working in, like
Oracle database
Oracle
information.
database?
Yeah.
Okay, that's wonderful. Okay. Okay, even if you have not done it, it is of prime importance that we at least understand the basic structure, how the softwares and the web designs are made. So accordingly, we will know where to place our ML model and how to get the input and how to get the output. Okay. Now, anything that you make work with, first of all, we need to ask some questions to ourselves that why we are doing it fundamentally. Okay. Okay. So fundamentally, what is ML? What is machine learning? First of all, let's just make also sure that there is some revision here. So what is machine learning? Anyone can share this. You don't have to think much here. You guys can directly share or like you can type the answer. So what do you think is machine learning and what is the purpose of machine learning? Sorry. So the idea of machine learning is to basically find patterns in the data that have been provided to you. Okay, so the idea is the data or the information that you provide to your system contains some pattern, maybe short term, long term. Okay. Now, ML algorithm, whatever you use, like if you have classification problems, you will use logistic regression, SVM, decision trees, maybe random forest. Okay. KNN, or maybe you can also look for clustering algorithms if it is unsupervised data. Okay, then we have regressors like linear regressors, as we are actually. So you can use regressors as well for your regression problem. So the idea is to kind of find these patterns, and if you recognize these patterns, then why we do want to recognize the pattern?
To get the insightful informations from the
Right,
data
right. So basically, many times it
for
is
business
about
purpose
like
or something.
the training. Let's say you do it on historical data. So the idea is, if I get some future data in future, would I be able to make the predictions? And we would we able to make these predictions with good accuracy or good roundabout knowledge? Okay, so the idea is to get some kind of benefit. So if you can predict these patterns well in advance, you can come up with a strategy also in advance, and that could like save the organization a lot of money, or it would be able to optimize different kind of processes. Okay. So basically what is ML or machine learning? Basically enables computers to find patterns in data and then use those to make decisions rather than being explicitly programmed to carry out a certain task. So conventional paradigms are that we have to explicitly program for every use case. Okay. Now ML is like, okay, we through the data we will figure out what is the outcome, and then we can plan for different outcome. What should we do? Okay. The internal function from the data is kind of derived more or less automatically by the machine learning algorithm. So the workflow is here simple. You have data with contains patterns, and we supply it to a machine learning model which finds the pattern and generates a model. And the idea is the model will recognize these patterns when presented with the incoming new data. Okay, this is clear.
Yeah.
Okay, perfect. Okay. And I don't think so I have to really tell you the major idea of data scientist, that fundamentally data scientists are a person who have these multidisciplinary skills, ranging from idea of maths and statistics, computer science, machine learning, so programming, subject matter expertise. Okay, so once you combine all of these skills, you become a great data scientist. And at some point, this does becomes a pretty big field of study after a while if you really go in depth. Okay. Okay, so first we will have to talk about the overall machine learning pipeline itself. Okay. So machine learning pipeline itself is a very iterative process, first of all. Okay, let me make that claim very loud and clear here. That okay, fundamentally, let's start with the basic. What do you think, or what does comes to your mind when I say the word pipeline?
Sequence of steps.
Sequence of steps. Very well, very well. Yeah. So basically, although pipeline is not 100% correct word to use here, but we will kind of use this because we don't think, or we should not think it as a one-way flow of data. That would be actually wrong. Uh, Actually, in ML pipeline, you will find that a lot of steps are cyclic, and basically it works in an iterative fashion, which is very true for a software development cycle as well. So there are different models, or there are different phases in the pipeline development. Okay. So what is the first thing that we have to deal with? What is the very first thing you should try to do when you are trying to become, or when you are trying to solve some data science problem?
Gathering the data.
What is a target variable?
Target
EDA?
variable.
EDA?
No, the very first thing that you should do is to understand the problem, what you are really solving. What are you trying to optimize? And of course, you in that you can also come to know about the data, like what kind of data you are dealing with. The first thing is called problem definition or requirement gathering. Okay. Firstly, if you do not gather all the requirements properly, no work. You will not be able to proceed properly. Or if your objectives are not aligned, ML model performance might not matter. Okay. So first of all is problem definition. So first you need to know what is the problem definition. So let's take an example actually. So let's say I want to optimize click-through rate on my website. Okay. So what should we do about it? So first of all, I need to know what are the parameters in my website that leads to better click-through rate. Okay, it could be the design, it could be the color scheme, it could be the content that I put on my website. Also marketing and how much advertisement we are making sure, or how many ads we are placing in different websites or different advertisers, so that it can redirect people to my website. Okay. So first of all, you need to know what kind of problem statement are you working with. Okay. And accordingly, you will need to know, do we already have some kind of data for this, or will we have to create the data, or we will have to buy the data from some other third party? So first of all, the first challenge is to understand or kind of do a requirement gathering. Okay. All right. So that was the first step. So what's the next step is? Next step is called data ingestion. Okay. Now what is data ingestion? Anyone?
Data source.
Sorry, I did not get it.
Basically getting the data from the source.
Yeah, so basically getting the data from the source in the correct format as well. Okay, so maybe your source could be a DB, maybe it could be an API, maybe you might be just reading some different format files, completely different format files from a server or a GitHub repository, or maybe they are stored on, it could be stored on an FTP server, it could be stored on a secure server as well. So you will have to kind of get the data from there. Now, there are different paradigms how to kind of get the data. Now, that is just one task. Okay, let's say you got the data. But then the problem could be about, is it in the correct format itself? So while you are doing data ingestion, sorry. So while you are doing data ingestion, you have to first of course fetch the data if it is not already available with you. Now it could be from multiple sources. Again, it could be file systems. File system. Okay, so maybe it is available in just a drive available with your VM. Okay, it could with DB database. Again, this DB could be local. This could be on internet or on the cloud. Then you might have a FTP server. You could have like a Dropbox. Okay, it could be from some API call. Okay, it might be in different kind of formats like JSON, XML. Okay, or simply RTF rich text format. So there are different formats it might be available in. Okay, and first you have to fetch the data, but then when you are fetching the data, you also have to ensure that it is in the correct format. So usually in industry we like to call it a ETL. How many people understand what is the ETL?
Yeah, it is extract, transform, and load.
Yes. So first extract is clear, like you are fetching the data, but then you also have to transform the data. Okay. So a lot of companies which have custom requirements make their own ETL. Although there are ETLs that are already available. So do you know the names of some commercially found ETLs or like commercially available ETLs?
Yeah, Informatica,
Informatica is
Ab
actually one of the
Initio,
big ones. There is Xplenty, which is a cloud-based ETL, I remember.
DataState.
AWS has something called Glue, Glue, something like this.
No,
Aluma is there, Talented is there, Stitch is there, Informatica, Power Center is there.
DataState.
Oracle has something called data integrator, something like that. I'm forgetting. So even that is used by a lot of people I know, Oracle Data Integrator. So I'm not sure you guys have used any of these, but Informatica Power Center is actually one of the biggest ones as well in the market. Okay. So these are commercially found or the commercially available ETLs. Now it depends on your company size. It depends on how much budget you have. And of course, it depends on what kind of requirement you have. If you have some very custom requirement where these ETLs are not working, you will have to make a ETL kind of tool by yourself in some programming language. So I remember me and my colleague made a ETL tool for a medical data set that we were working for while I was in my master's. And we had to make our own ETL tools because the current tools were none of them were actually working out very well. And in medical data is like slightly different than normally your day-to-day data. So we had to come up with our own ETL tool. So we wrote like 3,000 lines of code in Python to break down and kind of transform all the medical data into correct CSVs that we wanted. So that can also be a task for data scientist or data engineer that they might have to write the ETL as. Okay. And then load the data in your pandas or in your local databases. So now, depending on the database structure, you can use a SQL based data, RDBMS, or a NoSQL. So NoSQL is your like MongoDB, MariaDB. Although MariaDB, I personally find it slow, so I will not recommend anyone. Okay, so you can use a NoSQL if the data is kind of unstructured, but if it is structured already, if you have taken care of that and transform properly, then you can put them in some kind of RDBMS. Security wise, RDBMS would be slightly better than putting them in a regular file. Or maybe you can kind of convert them to pandas data frame and maybe directly start the processing. So this is just the second part of the overall cycle. Okay. Now what is the next step? The third step is data preparation. What is data preparation? From this onwards, you must know something. Anyone? What is data preparation?
Making the data into readable form.
Yeah,
No,
cleaning the
let's
data.
call that ETL will take care of that. What is data preparation?
Cleaning the data, taking samples out of the
Yeah,
population.
taking samples, basically, you can maybe kind of transform the data accordingly. Okay, normalization will be taken care of here. So data preparation would be, you have to understand in terms like you are preparing the data for the model training, okay, machine learning model training. So what kind of steps you do to prepare your data for training the model?
Normalization.
Okay, normalize. Anything else?
Missing data imputation.
Sorry, I did not get it.
Missing data.
Okay, you replace missing data with some kind of value, some pre-assigned values, and what else you do?
Standardization also.
Sorry,
Standardization.
binarization. Okay, fine. Binarization. Okay, fine. Okay. Anything else?
Remove correlated columns.
Yes. So you take care of some problems like multicollinearity or a low variance filter. Okay. So yeah, you will have to use your statistics knowledge as well. You will have to understand. Yeah, you can standardize, scale the data. You can remove the missing values. You can remove the noisy points or the outliers. You can try to bring the structure as close to a Gaussian if possible. So there are some transformers which will put or kind of scale the data more close to a Gaussian value. Maybe you can also try these kind of approaches such as no, it depends on data types. If it is numerical, we are talking. What if it is like in text data? Then first you have to convert it to a vector or some kind of a numeric representation, right? You might have to use some pre-trained embeddings to convert your text data into numbers first of all. Okay, so there are a lot of problems with different kind of data that we run into, and applying your machine learning and data preparation statistic knowledge, you prepare the data. Now again, remember, this might not be a one-shot event. It might have to be done in a different way for different kind of algorithms. Okay, then you separate the data into, let's say, training, test, and validation. Okay, and now what do you do exactly? You train the model. Now this is the part you must have done a lot right now, so I don't think so I have to explain how model training is done. Okay, so you choose your algorithm or you choose your set of algorithms. You pass on the training data, and through validation and testing data. Now these two will kind of go on, means on and on. So it will be forward, then again backward, forward, backward. So you kind of keep changing, because you try to retrain the model again and again by hyperparameter tuning or by changing the some control variables. Okay, and by applying test and validation data set, you come to know what is the accuracy in the real world, let's say. Okay, if everything goes smoothly, then you go for the deployment. So if you have decided that you have got the best model here, then you go for the model deployment. So understand, before doing model deployment on GCP or any service or server, there are a lot more previous steps that has to be taken care of. Okay, so remember that if unless you have not done that properly, model deployment will not make sense. And yes, once the model is deployed, you build some tools, or there are again commercially available tools which can monitor the performance of the model as we go along. So when it is deployed, let's say on a server or any live software, we also have to keep monitoring its performance, that what was its prediction and how correct the prediction was. Okay. So every step kind of feeds the data or takes the information from the previous step. And remember, there are some arrows which will identify, or which will hopefully tell you that it's an iterative process. It's not like a one shot that you do it and then you forget about it. Iteratively, it has to be always made better. This is all clear so far. Any questions?
Yeah.
Okay, all right. Okay. Now, of course, there is a bigger picture as well. Okay, there are two ways, and one is called online, one is called offline, and we will talk about all of this after a while. That what is online, what is offline. But you will understand that in a software development, this is just one part, that there is a data science pipeline. Then there are software ideas, scheduling, configuration services, notification services. You have to log your information, caching, so that your data will move on, and then there are data services. Okay, now we don't need to know everything right now. Okay, so we don't need to know everything right now, first of all. But again, we have to understand the idea of online and offline. Online and offline training. So first, let's try to understand what do I mean by online and offline. Okay, so again, these are just the same definitions. So let's look into online and offline properly first. Okay, guys. So mostly we are dealing with machine learning, especially around deployment. This is the question one has to ask: that is this system is gonna be always online, or it could be offline as well. Okay, so there is a very clear distinction between online and offline. So online is about real-time data. Offline is mostly historical data. So in online, real-time data means that we are dealing with change in data, let's say with like in terms of milliseconds. So here the performance needs to be good, especially not in just terms of accuracy, also in terms of time, that you should not be taking too much time in giving the inference, because we want the inference almost in real time. In historical data, mostly the data has been already been converted into files, or they are like cells in some kind of a DB. And there sometimes there is not a big rush over there. Okay, you have converted it and there is no real-time uh, information, that no real-time information is required at that very moment. So it's all right that even if you give the predictions after 6 hours, we'll be okay with that. So there are use cases for both of them, but like a lot of examples which we are going to use will be completely online. Now the problem with online is you cannot have a training over there. Training can only be done in an offline setting. Okay, and I will give you a reasoning a bit later that why only offline works for the training purposes. Now you could have your real-time data, and if your machine is fast and if your inference is almost real-time, you could provide the real-time inference back. Okay, inference means the prediction, basically we are talking about, that you provide the test data or the real-time data and you get back your prediction immediately. Okay, offline could be like, okay, you provide the data and we will process the whole file, and after 1 hour or 30 minutes we will provide you back the input. So there is no rush in the offline part. So whatever you guys have done is been completely offline. Okay, so online examples will also take like pretty good knowledge of understanding how web services works or how software services work. But again, I will give you a fair idea that how online services work and how offline services work. Okay. Okay. So do you know any example of an online service?
Maybe get market codes,
Sorry, I did not get it.
like getting the market codes for a financial services.
Market code for financial services. Okay. Anything else?
Computer vision related.
Computer vision is actually, especially with videos, it is actually very important. Stock market is there. So for any computer vision, especially if I'm dealing with a video, so video might be coming at 30 frames per second. So my inference needs to be really fast and we do not have the time to retrain our model. So basically what we do here is, let me give you a simple example here first of all. So let's say you are getting a video. So you have a camera with you. Okay, and you are getting some video. Okay, so video is nothing. Let's say it is 30 pictures in a frame, so 30 frames per second. So let's say you are running inference on each of the frame. Okay, inference is real time. Now what you can also do it, you can save this model or save this video and retrain the model. In an offline setting. Okay, the stock market is again real time. Like you need to make predictions with stock market, you have to do it in real time itself. Okay. A lot of you might have seen these streaming services like Hotstar, Netflix. So if they have to make certain predictions, or if they are just even streaming the data, that can be online, or that has to be basically online. Getting the data from some kind of API for stock market is almost real time. Okay. And again, there are so many services that have been designed in the industry that can be referred as a real-time system, where the data is coming by every millisecond or even microsecond. Okay, so over there, we do not try to retrain the system. It's just that we have a trained model already available and we are just doing the inference in real time. Okay. So online systems are a problematic system, because if your system, if your overall latency is very high, your inferences will be really slow. Or if your model is really heavy, then also the inferences will be really slow. And that is not something what we are looking forward to. So again, if I go back to this one. So we basically kind of have discussed this key stages already, that there is a problem definition. So you define the business problem you require an answer for. Then we have data ingestion. Then we prepare the data. So because the data is raw and unstructured, it is rarely in the correct form. So you fill out the missing values, you remove the duplicate records, normalize the values, correct different flaws like representations of the same value in different columns. You can also do feature extraction, construction and selection as well. You can remove outliers, noisy points. Okay. Then you segregate the data for your training. Then you train the model exactly with different cross-validation techniques. Then you have candidate model evaluation. So you assess the performance of model using test and validation subsets. Now you deploy the model. So once the model is chosen, is produced, it is typically exposed via some kind of API or embedded in decision-making frameworks. Okay. And then performance modeling is done continuously. So it is the model is continuously monitored to observe how it behaves with the real-time data and calibrated accordingly. Okay. And new data is collected to incrementally improve it. But we will talk about it, how it exactly does that. So the point is why we are learning all of a sudden about softwares and everything. The basically is having an advanced or programming skill. Basically, you want to put this to use into an end-to-end scenario. Okay. So remember, especially if you have directly come in data science or ML background, you need to have a very tangible experience into how to build an enterprise level distributed solid systems. Uh, your Jupyter notebook especially doesn't qualify as a great piece of software. Okay. And of course, it doesn't make you a proper software engineer either. So what you have built is a good prototype. Okay. But still we will have to push it through the engineering roadmap, software engineering roadmap. Okay. So you will need to put up a proper team of software engineers by your side to take your disposable proof of concept and turn into performant, reliable and loosely coupled and scalable system. Okay. So remember what you have built with your machine learning model is it's just a POC basically. Try to understand it like that. But actually to make it work in the real world, you will need different skills and hopefully wherever you will work, you will have different set of people with these different skills who can come together and solve the problem. And then only it basically becomes a proper software or a proper system which can scale and which will be completely reliable in the face of real-time data as well. This is clear for everyone? Okay, all right. Okay, so I would actually like you to note down these points if you want to. The main objectives, what do you want to, because you need to know your objectives first, okay? So first, the main objective to build a system is to reduce latency. What is latency?
Lagging.
Lag. Oh, okay, time lag. Let's call it simply time lag. So whenever we transfer some kind of packet from one device to another through a network, there is always some lag. Now, if the lag is in milliseconds or in microseconds, then it's okay. You will not notice. But if the lag is in seconds, then definitely user starts to notice. So first, you have to always ensure that your model prediction and overall software design should be incredibly fast. Okay, so you reduce the latency over the network. Now this model and this software that you have built should be integrated, but should be loosely coupled with the other parts of system like data store, reporting, graphical user interface. The idea is if one system goes down, it should not be able to take down the whole system as well. If the inference model is not working, it doesn't mean the actual software should just stop. Okay. You might be able to put some kind of exception which will let the software run nevertheless. Now, how many people understand in software or like in software or hardware, what is a scaling up vertical and what does it means by scaling up horizontally? When I say scale up horizontally, what does it mean?
Scaling vertically, I believe, is adding to the existing system more servers or something. I mean, for you
Mhm.
consumption, but horizontally is changing it all together. I mean, moving to a higher configuration.
Okay, let me explain how this works. So in software world, when we say software and hardware, so when we say there are two kinds of scale up, okay? So horizontal scale is adding more machines, okay? So when I'm writing M1 means it is a different machine, M2 is a different machine, M3 is a different machine, okay? So you can think about as, so have you guys have the classes for like Scala or something like that? Scala or Hadoop?
Not yet.
Okay, fine. Those are in, I think you're in, I think next to do topics anyways. So basically in a Scala, Hadoop or Spark, fundamentally idea is take each machine is as it is, but now you are assigning a lot of machines. Okay. So you have these multiple nodes and you are trying to join these multiple nodes for better or higher performance. Okay. And maybe some node is responsible for the description and everything. And let's say this is responsible for DB as well. Okay, and there are different nodes available, and these just are the computers, various computers. So you, when we are talking about scaling horizontally, now think about it, one floor data center. Okay, I will explain you how this works. So this is the floor. Uh, if I just keep putting more machines, okay, let's say there is no rack system or anything. Okay, you can just put the machines on the ground itself. Okay, so if you put more machines, let's say more number of CPUs, what will happen? It will take more space on a horizontal level, right? Agree?
Yes.
Okay, just give me 1 minute, guys. 1 minute. Okay, all right. So scaling up horizontally is clear. Like how do you scale up horizontally? Because let's say there is no rack system, you are putting all the CPUs on the surface, let's say on the floor itself. So if you scale up or if you increase the capacity of your system, you will have to just put more CPUs, which is gonna take more space in the horizontal. Okay. Okay, let's say each system is one core system only. So each one has a single CPU. Make sense? Now, rather than that, what you could do is you can buy a rack. You understand what is a rack? Anyone see the rack mounted server?
Yes, yeah.
So what is the idea in rack mounted servers? So basically there are racks put in like your server systems. And okay, so this could be a good example. What you can do here is you can increase the number of RAM, hard disk, and even the CPU cores here inside in a single box itself. Okay. Now these are like incredibly costly, and so you put the rack, and again you can sequence these rack into a machine, like or this kind of racks are available. So each single system that you are looking could have like 256 or 512 GB of RAM, TBs like 8 or 10 TBs of hard disk memory, 24 cores, 32 cores of. Okay, so this is like a vertical scaling. So in vertical scaling, what it means is rather than putting 24 16 systems, okay, we build a single system, okay, which has 16 cores, maybe 256 GB RAM. Okay, This kind of scaling in a, let's say in a single system or in a same number of system, but you are increasing the computational power and the RAM and the overall space. This kind of scaling is called vertical scaling. So you guys are clear what is vertical scaling and what is a single horizontal scaling?
Yeah.
Okay. So data center like Azure data center is an example of vertical scaling. So Ujjwal, actually, I would like to call this, that would be actually perfect example of doing both. It also has multiple computers, but each computer is also very powerful. Okay. So it is not that it is not horizontally taking space, but each computer itself can be made powerful by addition of more RAM or hard disk space, or sometime even a more core processor. Okay. A multi-core processor. So it would be any kind of data center is actually example of both. It is horizontally scaled as well as vertically scaled. And after a while, there is a limit how much you can vertically scale. Okay, you might know on your motherboard there is a limit actually how much RAM you can put. It is not infinite. Similarly, maybe anyone even owns a motherboard which has support for two CPUs, two CPU chips. Very few people will have that. Even I had that back like a couple of years ago with me. That I could put two Xeon processors over there, Intel Xeon processor. So if I one processor has 6 cores, the other will also have 6 cores. Total, I get 12 cores. But there is a limitation of how much you vertically can scale. Horizontally is something area based dependent, and this is why the data centers are like open in far off remote places where the land comes cheap, and they can also horizontally scale if they wanted to. Is that clear, Ujjwal? All right. So yeah, you want the software to, or basically whatever piece of system you build, it should be able to scale both horizontally with more number of computers and vertically if the similar number of computers are just made more powerful with higher number of CPUs and RAM. Okay. It should be kind of message driven. It should be able to communicate with different systems via asynchronous non-blocking message passing. It should be able to provide efficient computation with regard to workload management. It should not like hog the whole CPU or GPU that you are using, and it should then like block the existing programs altogether, because then okay, fine, your inference is running, but then rest of your system becomes slow. That is not something people will like. It should be fault tolerant and self-healing, means there should be some breakdown management, although self-healing is kind of a tricky word to use here. Okay, fault tolerant, yes, even if some fault is available with the data or incoming stream, it should not like shut down immediately, or it should not break down. And it should support batch and real-time processing. Batch is like, okay, how many people understand what is a batch processing?
Yeah, doing a single task multiple times for
You can also think like
yeah,
you can collate like multiple tasks and you can do it in a single go. That is what a
yeah.
batch means. Okay, real. Okay, so how many people understand the difference between IMPS payments and NEFT payments?
One is an instant one and
Yeah.
another one.
So IMPS is an instant money.
Mobile,
Okay.
through mobile. IMPS is through mobile something, communication. Right?
IMPS, no, I'm pretty sure I can also do it from my internet banking as well. We have IMPS over there as well.
No, no, I'm saying like it's pretty faster than NEFT. NEFT has to go through a cycle, right?
Yeah, you are right. No, it's not like, okay, so the idea is which kind of processing they allow. So real-time processing is your request comes and we will have to process it immediately. Okay, that is the online system. Batch is like, okay, fine. What RBI does is I think the NEFT cycle is what, like 30 minutes these days? I'm forgetting what is the cycle for NEFT right now. So what it means is, let's say you start your process. So let's say the cycle goes like the payment will happen at 9 or at 9:30. So let's say you scheduled a payment at, or you told the bank to make a payment at 9:01. What will happen? All the payments throughout India, whichever will go through RBI, will be kept with be collecting. Okay, let's say in some kind of an array, and the whole array will be executed at 9:30. And again after from 9:30 or some 31, again a new array will be made. All the payment collection would be collected over there, and again at 10 they all will be processed immediately. But in IMPS, your request comes at 901. Within maybe 10 or 15 seconds, it has to be processed. So this is real time. Okay. Your UPI is also like real time, but NEFT or RTGS are not real time. They are batch processing. Is it clear?
Yes.
All right. So let's talk about architectural systems. So there are various architectural systems in software design that people kind of prescribe or utilize those ideas to build the software from. Okay. So the very first idea is about reactive systems. So anyone knows what is a reactive system?
No.
Okay, no problem. So basically, reactive systems is a kind of a design paradigm, software design paradigm, which is applicable with these four properties, which are like responsive. Okay, the system responds in timely manner. Then it needs to be elastic, where it should be able to be responsive under varying kind of loads. Then it should be resilient. Okay, system stays responsive in the faces of failure, and it should be message driven. What does message driven means? Basically, the system relies on asynchronous message passing. Okay, so what kind of softwares or what kind of examples we can take for reactive systems? So there are various vendors in this space, like Scala, React is there, Elm, Lightbend, which kind of follows the reactive principles, okay, or reactive system architecture. Now we have service-oriented architecture, which is, let's say, SOA. So now SOA is, it means there are a lot of services involved. So anyone understand what does services means basically in terms of programming?
Services are basically created to support some of the application, preferably online applications which have a front end, and these services won't have any front end. They will be just providing services from
Exactly.
collecting. Yeah.
Yeah, anyone, I understand like a lot of people might not understand this word services. So first, let me explain this word first. So what does services really means is services is nothing but it's a internally we think it as of a function itself. Okay. You can think it as a function. Okay. Now for different tasks, you can build different services, and collectively these services or service oriented architecture, for every major module, there is a service available. Okay. So the idea is, especially in cloud, a lot of these architectures actually merge over there and service-oriented architectures work there. So any kind of like metering or billing system, any kind of provisioning system like service catalog, order management, these kind of even abstraction or like service bus, governance, any kind of registry happens to be a service-oriented architecture itself. Okay. So the idea is in service for everything, let's say for application, server, management, runtime, operating system, storage, everything has a different service. Okay. Now in microservice, there would be a small difference that in microservice, some systems like operating system, hypervisor, storage, network are actually common. And on the top of it, services are written. But in a SOA architecture, for everything, there is a different function or there is a different service available already. Okay. So now service architecture could be in a very different ways available to us. So there could be uh, a simple SOA which just can deal with request and response over internet. Okay. Then there could be complete orchestration. Okay. There could be a composite service which kind of deals with the rest of the services like service 1, 2, 3, 4. There could be a complete choreography. It could be like going in a circular or a cyclic fashion, but everything is timed, so we know which one is gonna fire when. Okay. So a lot of cloud development, and as I told you, billing and orchestration and registry modules are mostly service-oriented architectures. Then we have streaming architecture. Now, what is the streaming idea? Okay, what is streaming first of all?
Amitash, if you don't mind, can you start from that? What is service-oriented architecture?
Sorry, could you repeat the question? Hello.
You said like what are services, right? Can you please repeat that?
Okay. So basically, okay, the very first line kind of explains this one. Basically, the concept is to decompose business problem into services. Okay, let's say I go to your cloud and you offer me let's say VM. Okay, so now your VM needs to have different. Your VM needs to have an operating system. Okay, so you are offering me operating system as a service basically. Okay, or a software as a service. Anyways, you can think of. Require, let's say, SQL server. So you build a separate server for providing me SQL server. Okay. Similarly, different use cases such as like billing. So you can also provide me with billing, or you can also provide me with ticketing module. Okay. So you build these services, and you build these services from like ground up. Okay. So like for even for hypervisor, you have a service. Even for a network, you have a service. Okay. So a lot of cloud architectures are actually good examples of service oriented architectures itself.
API service.
Service is like a function. Okay, service. Okay, do not overthink this. Service is like a function. So if I want to have, let's say, uh, Ubuntu OS, okay, Ubuntu OS on my VM. So you provide that as a service to me. Okay, that Ubuntu is will be provided to you. I want certain network device to be attached to this VM. So you provide this network device as a service to me. I want like SSD rather than a conventional hard disk. You provide this as a service to me. Okay, so again, I cannot touch this hard disk at any point because the VM is on cloud. So I cannot really go ahead and touch this hard disk. So you provide me this service, which again is just a function internally. On calling that, I can access my hard disk over the VM. Okay.
Okay.
All right. Okay. Now, what is streaming? Okay, does anyone knows what is streaming?
Continuous flow of data between the
Yeah, very good.
devices.
So streaming, Netflix is a good example. Hotstar is or Amazon Prime are really good examples. Okay. So even in India, there are like a lot of OTT platforms. Z5 is there, and ALT Balaji is there, and I think means there are multiple players even in India right now. So now, what is the problem with streaming? Now, streaming has couple different modules available. Okay. So first of all, there is a producer. Okay. So producer is a server or producer is a system which basically generates and sends messages. Okay. Now there needs to be a consumer which subscribes and consumes the messages. So let's say a Hotstar server is your producer, let's say, and you are one of his consumers. Okay. It could be Hotstar app, it could be Hotstar website as well. Topics. Now, various stream of records. Now, the problem is the producer is producing different topics. So on Hotstar, you have different movies, different TV shows. So one consumer, let's say at one time will be just watching or kind of streaming just one data. So it has to be segregated into different topics. Okay. And based on those topics, only the current stream or the correct stream is shown to you. And then you have stream processor, which manages or which processes the message in certain manner. So this is where the data transformation and ML models are put there, so that the stream processor basically decides how the data needs to be transformed for your application. Let's say you consumer one is watching in 360p and consumer two is watching in 720p. Okay, different resolution. So on a mobile phone, maybe 360 or 480 is good enough. For a desktop or for a proper screen, 720 is the minimal, or maybe you want a full SD over there. So accordingly, basically stream processor will decide what kind of data transformation needs to be done. Let's say if it is trying to make a prediction in real time, then the work will be done by stream processor itself. So in a stream processor itself, you will have to put the ML model. So almost any kind of system which is real time or basically which is streaming data. Now it doesn't have to be video data. It could be simply audio data, or like in terms of stock, it could be numerical data. But there is a streaming architecture available, and actually there is a good tool if someone wants to learn on their own. So there is something called, one second. Apache Kafka. Okay. So for streaming, this is what we use most of the days, or there is this, I'm forgetting, Spark streaming, right? So you can also use Spark streaming, okay? Or my personal favorite is definitely Apache Kafka. So if ever at any point you want to stream some data in real time, you should either look for Apache Kafka or Spark streaming. Okay, these two are like really good open source tools that can help you stream any data in real time. Okay, so Spark streaming is basically kind of an add-on, especially when you are using a distributed system. If your system is highly contiguous and continuous, basically you can still stick with the Kafka. Kafka also supports a distributed streaming platform, so that should not be an issue. And both of them are open source and free, so you can use either of them. And again, they have the same idea. Basically, they have your stream processor, they have your producers like DB, and there are various applications. And you can build some real-time pipelines and data pipelines or streaming apps. And again, it is horizontally scalable, fault tolerant, and wicked fast, and run in production in thousands of companies. So you can understand, even it is open source by Apache. A lot of companies are using Apache Kafka right now for building their streaming pipeline. Okay, then we have a Lambda architecture. Okay, Lambda is kind of a how do I explain this? Lambda is kind of a hybrid model, okay, which uses both layers. So there is a speed layer, there is a batch layer. So batch layer is that batch processing, speed layer is the real-time processing. Okay, so you can handle both of them. So Lambda architecture is designed to handle both real-time and historically aggregated batch data in an integrated fashion. So basically it separates the duties of real-time data and batch processing. Okay, while the query layer will look like when you will query something from the REST service, it will feel like it is all same. There is internally just one system, but technically there are two systems. One is the batch system, the batch layer, where the batch is run in various services. And then there is a speed layer, which actually has a streaming service. Okay. So in speed layer takes care of this problem of streaming the data in real time. And batch layer takes care of this problem of having information in various batches and processing them in the batch. And this kind of architecture is called a Lambda architecture. Now, what is a microservice architecture, or what is a microservice first of all? Sorry. Anyone? What is a microservice? So, okay, first let's say microservice versus service. So in service, everything, okay. Let's say this is application. Okay, this could be OS, this could be hypervisor. Okay. This could be your network. Okay. Everything is basically a separate service. Okay. So for each we have a service. So this is a different service architecture. So this is service 1, service 2, service 3, service 4, something like this. Okay. What is a microservice architecture? Over there, there are some commonalities. So from OS level, OS to down, OS, hypervisor, and network, and of course processor and all the hardware, everything is same. But then the microservices at the level of software can be provided, but all of them are utilizing the same OS, same hypervisor, and the same network and the CPU. Okay, so microservice architecture would be using a way, or the way you can think as like for any microservice, that the resources are common and microservices or the such APIs basically run on top of these. Okay, so that's the small difference between a service and a microservice. The idea is, in a microservice, Each microservice doesn't get a dedicated OS or a hypervisor or a processor. Okay. In service, it could be the case that for everything there could be a dedicated system, or there could be a dedicated hardware piece, or there could be a dedicated software piece to handle it. In microservices, still operating system and the even runtime environment is actually common. So for most people actually who are designing in web, they actually design on microservices, not on services. Okay.
Okay, understood.
Did you have any questions? Hello. Oh, sorry. So basically, Microsoft services is an architectural style, okay, which is a collection of small, autonomous, loosely coupled, and collaborating services. So again, in software world, you will find these two terms reoccurring a lot. So there is something called tightly coupled. One is called loosely coupled. What is tightly coupled? What is loosely coupled? So tightly coupled, which is sometimes also referred as heavy coupling. Basically, what it means is the hardware and software are kind of interconnected. Okay. So the idea is, let's say you build a service or a software. Basically, it will be also be put in that same system, utilizing the same system CPU, RAM, as well as the let's say any kind of network or data hard drive. Okay, that is called tightly coupled. So the processing is also has to be taken care of by that same hardware wherever you put there. So the software and the hardware becomes tightly coupled over there. So anything that you mostly install, let's say on your system, okay, let's say then there are dedicated games, right? So okay, does anyone plays here like computer games here?
Yeah. Yes.
Okay, so like which kind of games you play?
Battlefield.
Battlefield. Okay, no, that will not work. That's a good example here. Okay, I will come to the Battlefield example a bit later. Okay, so there are dedicated games like Halo. Okay, Halo can be played standalone on your system, but Halo has a firm requirement on your system. Okay, so it doesn't, let's say you don't even have to connect to internet. The whole storyline and the whole game can be available on your system itself. Okay, Halo was, I think, released back in 2002, so it's a pretty old game. Let's say you are playing Halo, so it's a standalone game. It doesn't require network connection or anything. Now it is technically tightly coupled with your system because it requires all the resources to be present on your system. It is not going to connect to internet for any kind of resource. Okay, but when you play like some games like PUBG, okay, okay, now there are different variations, or there are, okay, so in PUBG, of course, it has some dependence of your system, but the overall game or the server is somewhere else. So fundamentally, your app, let's say your PUBG app, basically connects with the server. Okay, and so many thousands of users do. Now this server has no use or any the main code, that whatever the main code is available of the PUBG, that is not running on your machine. Okay, your machine just runs the variation or just the uh, PUBG instance for your application or your user. Okay, but the main services, because there are a lot of services which are interacting with the main server, the computation cost is actually handled by the server itself, main server, not your machine. So such services could be called loosely coupled. Okay, that it might take some RAM on your system, but it doesn't take too much processing from your system because the actual processing is happening somewhere else. So most of the API idea is loosely coupled. Any dedicated software is tightly coupled, which let's say completely runs on your system and your system itself. But most of the APIs, their core processing happens on some kind of server. So mostly the architecture is like this. So let's say I have a server. Sometime you have a middleware. So the routers and everything. And then you have your front end. Okay. So the idea is, let's say I have to access anything. So it would be through an API. So first you will make a request. This request is forwarded here. Server will decide if you are an authentic user. Then it will give you a response. Now it could be a successful response. It could be a response of a failure as well. Okay, so basically what happens is this can be done through in an API fashion. Okay, application programming interface. Now APIs do not exactly take much computation power on the front end on the user. If they have to do something, they will actually take the computational power or even use the RAM of the server itself. Okay, so these systems are basically called loosely coupled, and any kind of dedicated software is called a tightly coupled system because it basically interacts with other software and the hardware as well. But any kind of microservices, which again is basically idea from API, is a loosely coupled system. Okay. Now, basically, these services usually communicate through synchronous protocol using HTTP or the REST protocol. There is also asynchronous protocols such as AMQP. Okay. Although in website designing or web design, we mostly stick with the REST paradigm itself. And these can be, the best part is each microservice can be is independent, mostly independent of each other. So let's say microservice 1 is accessing database 1, microservice is access database 2, and microservice 3 is accessing database 3. Now let's say database 1 is about, let's say, Google Photos. Okay. Database 2 is from YouTube. Okay. And database 3 is about, let's say, image search. Okay. All of these systems are fundamentally different from each other, and each of the microservices, let's say the database 3 is of Google Maps. All of these microservices are different from each other. So even if the Google Maps is down for some time, it will not impact YouTube or Google Photos at all. Those will be completely working. So this is the whole idea that each API needs to have its own database in order to be decoupled from service. Yes, its data, if it is dependent on some data, it needs to be different, or it needs to be decoupled with other databases. If all of them are in same database, if the database system goes down, every microservice will stop. So ideally, in the correct design, each should have its own database or its own data source. Is it clear? And yes, what is REST then? REST is basically an architectural style for developing web services. And basically it is built upon whatever the existing features are already which is available for hypertext transfer protocol, that is called HTTP. It basically allows transferring, accessing, and manipulating textual data representation in a stateless manner. It means is the application communicates agnostically. So whichever system you have, if it follows the HTTP protocol, you can communicate through the REST paradigm. Okay. A RESTful service is exposed to Uniform Resource Locator, URL, which provides the capability of creating the data, requesting or updating or deleting the data, CRUD, which is, if anyone knows databases, they will understand what CRUD operations mean. And similar commands or similar protocols are available within the RESTful APIs. And it is best used to manage system by decoupling the information that is produced and consumed from the technologies that produce and consume it. So consumer is the client, and the producers could be either the database or the server itself. And basically the idea is to decouple this whole idea. So again, through a REST client, you make a request. Now REST services are running in backend. Here it will decide that data needs to be put from the database, or it is some kind of a information that they want that a server can make a computation and provide it to the user. So you can see the data and the information from on the database as well as the server capacity is at one place and the client is at a different place. Okay, so let's say you wanted to do a really complex calculation. Okay, so you, let's say, do not have the memory or the processing power with you. So what you do is you provide this request to the server, which can do this mathematical calculation for it. It will do the calculation on its own cost, so whatever is CPU it has to run, and then it will simply provide you back with the results. So this is the loosely decoupled, or this is the loosely coupled idea, that they are sharing information, but at no point they have to share or they have to be dependent on the resources of the user's device. Okay, user's device could be extremely low powered, but just because they are on internet and there is a API protocol that can take care of it. Is it clear?
Yes. Okay. One query here. This
Sure.
REST API is always used between a client and this server interactions, or it can be implemented between two servers or
Yeah, of course.
service.
Internally, there could be a lot of servers which could be communicating with each other. That's completely correct.
And REST can be in between these two
Yeah,
servers.
totally. REST can be in between. Even let's say, because let's say Google kind of shows you so many ads. So of course, it also is connected with various ad services, right? So these ad services could have their own servers, okay, to broadcast certain ads or to
Mhm.
provide the info to for Google to kind of, or Google could have made its own ad services servers, okay. So these could be in a geographically different regions altogether. So of course, through API calls, these guys communicate through even server to server level as well. So at one point, one server becomes the client, other server is the server for that, and this can keep on changing.
Okay.
Yeah, so the web backend design, if anyone has worked or if ever you had worked in this paradigm, people are usually familiar with what is a RESTful API, what are HTTP protocols, and how does the API transfer or API information basically works. So this is something that is in really in a hot demand right now. That a lot of people want this call or this they want to understand that how the this works, and basically, so I will just show you that even when we look for let's say, how do I say, interns even at our company right now. So let me just show you one of our posts. Okay, so one sec. So like last to last week, we put this job kind of internship call. Okay. So we got like 140 calls, and you can see that these are, let's say, your requirements, major requirements for AI intern. Okay. But you can see there are some bonus skills, and in bonus skills, we have deep learning, Django, RESTful API, and Unix programming. So any kind of web-based interface, if you have to build, you will need to know some RESTful API. It is almost like given, like even if people do not talk about it, it is kind of understood that you need to understand something about RESTful API, how to create these RESTful APIs and how to deploy your services. So your model prediction could be a RESTful API actually, that you provide some data and then the server will do all this processing and it will return you the results.
Okay.
Okay, all right. Now, how do you architect a model or ML pipeline? Okay. So traditionally, pipeline involves overnight batch processing. Basically, the idea is we collect all this information, let's say from one day, let's say, and at the night, we kind of retrain our model and update our model. Okay. So the problem is, and many times the problem is when we have time sensitive data, and especially in any kind of real-time prediction or any kind of real-time, how do I say, any kind of real-time streaming, such as Netflix recommendation engine, Uber arrival time estimation. Okay, so these things have to be done in real-time data. Okay, now the problem is in real time you cannot retrain your model, otherwise it leads to degradation, and I will explain you why it will happen actually. So what you do exactly is we have to come up with a kind of a custom idea. Okay, that we can take the stream data, we can do the feature engineering, we can transform the data, but we will directly pass it to a deployed model. Okay, and then we will get our evaluation and the scoring. But training will happen only in historical perspective only. So you collect the past data, you can put it in a historical data as well. Again, you can do your feature engineering, you can do your training and evaluation. And once the best model has been selected, it can be deployed as the new model, and then the scoring will begin. So how does this happen? So what happens is a lot of people basically don't understand this small part is. So how many people know what is a version control?
Yeah, version control is the uh, uh, thing which the software developers use for
For
while
example,
building.
GitHub. Yeah.
Yeah,
The GitHub is there.
basically the tool is called Git actually. GitHub is kind of a repository.
Yeah.
The tool is Git actually. Okay. So Git was also, I think, developed by Linus Torvald itself, who was creator of Linux actually. So Git is basically kind of a version control. So basically what happens in real time when we do software development, we have different branches ongoing. Okay, there could be a prod branch for production. There could be CT. Uh, there could be some kind of a development branch, DEV. And then there are personal branches for a lot of own developers. So this is, let's say, developer one. The personal branch starts here. Let's say for developer two, personal branch starts here. So what happens is after a lot of these mergings and whatnot, software versions keep on changing, or your version keeps on changing. So sometimes you need to know what is your version, or sometimes you need to revert back to some of your previous build. So through version control, you can do it. So what there is some kind of convention usually. So you understand how version control works. What the three means? Actually, there could be actually four as well. Actually, when I say version 1.1.2.1, what does all of this means?
I have no idea. I think you can explain.
Sorry.
Basically, it is a first version of 1.1.2.
It can be related as major release and minor releases and changes.
Yes, very good. So which one is a major release?
One, the the first part, the one.
Yeah. So, okay, let me explain how this works. Okay. So whenever you see this kind of encoding in any software, even in an Android app, you can see this. You can go in details and you can check which version you are running right now. Okay. So basically, the very first one is called major release. Okay. This one is like major release, like Python 1, 2, 3, 4. Okay. So like we are at Python 3.9, means Python 3.9 is going to release very soon. So if it has to change to Python 4, that would be a major change. Okay. So they are not going to make 4 every time. For Python, it is like once in a decade kind of thing. Okay, so this is called a major release, or of course, this is the minor release. What is this? And what is this?
Object version.
Now, of course, different people use it in different ways. I'm not saying that should be it. So this fourth one is not necessary, or this is not like mandatory. Okay. A lot of companies actually do not go for the fourth one, but the third one is the called patch. So you have your major release, minor release, and then you have patches. So patches are the temporary fix you have to do for your security or something has been broken. So most of the updates that you get in Android are basically patch. So recently so I'm using, I have an iPad. So it keeps updating its iOS. Now I will have to look exactly what iOS I have right now. Let me check it anyways. Okay. So I have this iOS with me. So let me just find the version here. So because I'm forgetting what is the exact version I have on my system right now. It keeps on updating and I don't check it that often. Okay. So yeah, I have like iOS 13.6 right now. Okay. So So basically 13 is the major version. 13 iOS 13 is the actual version. And whenever they are doing some minor releases, that is 6. And usually Apple has a habit of merging a lot of patches together. But like Android is gonna sometime update like patches by as well. So if it finds some security bug or security issues, it immediately kind of goes for the patch and it basically updates it. So a lot of companies will have this 13.6.1. Okay, and if you have not released it, usually the convention is if you have not released it, you keep the first number as 0 and then you can put whatever number. So 0 means ideally it has not been released yet in the market. Okay, the first release is basically 1 and afterwards you can follow the convention as you go. So maybe if you want to see, maybe I can also show you somewhere else. So if you want to see this in proper way, you can go in help of your browser and about Firefox. See, right now, I'm not sure how updated it is. It is 79.0. So sometimes you will find some other numbers. So 79 is the major release version. Okay. So from the start, when Firefox started with its first version, 79 versions it has come out with. Okay. And of course, this is for 64-bit, and there are sometimes some minor versions also available. In your Android, if you were to see it, you will also see the patch version as well. Okay. Okay, so what my point was, what the actual point I was gonna try to make over there was, so what you have is, let's say you have your ML model V1.1. Okay, let's call it V1.1. Okay, and this is live, let's say. So what you do in parallel cycle, what you do is you train your next ML model V1.2. Okay. And at some batch processing, basically what you do is you ship this model and you make this model live and the previous model is taken off. So you do not retrain this model in live. You do not train the live model. You have a copy of model V1.1 and you retrain and you call it V1.2. And at some point when you have to replace, you replace the ML model with V1.2. And now this is live. Okay. This is clear?
So the version will always be 1, and
Yeah, unless there is some major change which you have brought to the system. Usually the major version is, let's say, changed once in a year. Okay, once or twice in a year. Okay, major version is not changed like every month or every day. So if you have to change something every day, that is usually the patch number. And usually in the software cycle, I'm trying to explain you, usually the minor version changes every week or maybe it can change every few days as well. Okay. But usually that is the patch version. Some days in Android, I sometimes see in different applications, they change their patch numbers sometimes multiple times in a single day because of some security or imminent flaw. They have to do that. Usually they change the minor version in a month, definitely, and they change their major version in almost an year. Now, different companies have different cycles. So I'm not gonna say that which is correct or which is wrong. Everyone has their own convention to work forward with. Okay.
okay.
So it is always remember major version, minor version, and patch. There is also something called fourth, which is called fixes or something, but not everyone uses that idea. Okay. So in most standard companies, it is major dot minor dot patch. Okay. So similarly, this is what you will also have to do is you will have to basically recreate or not recreate, retrain new models, and at different times it is switched with the old model. So old model is kind of disabled and the new model is made live. Okay. And this is how the iterative progression of model, or this is how you iteratively build a better model. And you keep it live and you keep scoring it. Get the basic idea what is happening here?
Yes.
Okay. Remember, again, I'm just repointing this out. You do not do any kind of training or reevaluation in the real time or streaming data. Okay, you can directly get run it with the deployed model for the inference, or you can save that in streaming data and convert into historical data and later retrain it. And in a overnight batch process, you can replace the deployed model with the newer model. Okay. So there are two ideas: online model analytics. Again, remember, it is called model analytics. Basically, it just is model is applied for real-time decision making, means it is used for real-time inference. Offline data discovery is you can do analysis and basically you can train your model on the historical data in a batch processing mode. Okay, so the training or retraining is always done in offline setting. And if you just want to do some kind of analytics in online mode, yeah, you can do it. You can directly run it through a deployed model and you will get the inference in real time. Okay, just give me 1 minute, 1 minute. Okay, just in detail. So basically, how do you do a data ingestion? Okay. So now you can do it through request. You can stream the data. You can use NoSQL or SQL databases to store large volumes of rapidly changing data. Now in offline, what you could do is you could have a raw data source which you can take through ingestion services. So you can build your own orchestration service. Okay, and you need to have a dedicated pipeline, of course, for each kind of different data sets. And within each pipeline, data is partitioned to take advantage of multiple server cores, processor, or even different servers. And basically,
Can you go
yeah.
back to the previous slide?
Sorry. What did you just say? I did not get the whole thing.
Can you go back to the previous slide?
One sec, one sec.
The ingestion.
The offline one or the online one?
Ingestion. Yeah, data ingestion. So this
Yeah.
is the first step we take.
Mm-hmm.
Explain this one. Okay. Okay. Yeah. Thank you.
So these slides and all the content would be available. Actually, there's a Google Drive. You can ask Abhishek to share it with you. So all of these slides are already available to you. Okay. Okay. So the idea is very simple that if you have dedicated data source, and that is going to be easier. So if you are using or coupling data from various sources, so say B, C till X, let's say, so you can have different services to handle each ingestion, and you can again accumulate all of them through in a raw data store, or you can have your proper database to accumulate all of this different data into a single database. Okay, or different tables in a single database. Okay. In online, basically what is the issue is, again, you can use Apache Kafka over there. Apache Kafka has its own running data bus, which is a kind of enterprise scale data bus. And here you can kind of put all the apps, NoSQL, Oracle databases or caches. And you can also link up your web apps, custom apps, microservices, monitoring tools, analytics tools. Okay. Now it depends on enterprise tech stack. Again, it is not that there is only one way of designing this kind of streaming service. There could be different ways, but this is like one of the common architectures I can show you. Now, I think you know what is data preparation. I don't have to explain you data preparation. So basically, once you ingest the data into various data sources, may it be DB or through the streaming service itself, a distributed pipeline is generated which assesses the condition of data. It basically looks for different kind of format differences. Again, ETL, we are talking about ETL here. What kind of format differences we have? Do we have an outliers, trends, incorrect, missing or skewed data, or rectify any anomalies along the way? You can also do feature engineering here. Basically, the major things are extract, transform, and selection, or load. Basically, load the correct data. And both feature extractor and transformer should be structured with composition and reusability. So you should always think about, whenever we are building this feature extractor and transformer, it should be reusable first of all. So you should be able to use it with different data pipelines that you have built. Okay. So, and it should be compositional. Compositional means different parts could also be separated easily if we want to.
Okay. I have a doubt here.
Yeah.
So data preparation, how is it done on a online and a live scenario, like in a Kafka uh, uh, channels? Live data is continuously flowing in, and how ML engineer prepares the data on a live? Is it taking a sample of data and then doing it? So how is it done on a live?
No. So there are basically these functions that are built there. We are deployed this along with the Kafka pipeline, which can transform the data as the data comes by. Okay. So if you were to, let's say, use Apache Kafka for your streaming. Okay. So we can write functions in, let's say, Python. Means Kafka Python is also available now. Okay. So you can basically write functions along in Python itself by using Kafka Python if you wanted to. And over there, you could transfer or transform any data that is coming in real time. So again, you can just take the output from Kafka pipeline and you can pass it to any Python or sklearn feature transformer.
Okay.
So basically what it is, Kafka, there is a Kafka consumer client that basically reads the data. Okay. And whatever the message is there, it is literally a data point. Okay. Now you read that data, information, and then you can pass it to any Python object. Once it is passable as any Python object, then it doesn't really matter.
Okay.
Now, actually, Kafka was originally, still I think originally is in Java. Okay. So that's why Kafka Python had to be launched so that Kafka pipeline could be also be workable with Python. Now, again, we are trying to give you a general idea. Again, it depends on which industry or which company you go to. Everyone has their own idea of the pipeline and it suits their client base or user base. So it makes sense for them. So again, I'm not going to say there is a general idea that this is how things should always be done. But yeah, there are some core ideas that kind of remain very similar in most of the companies. And that is what we are trying to cover. Okay, not everyone is deploying through GCP. Most of the companies still deploy through AWS. A lot of companies are deploying on Azure. Okay, so we are just giving you one example how things are done. Again, by no means you have to think like, okay, this is the way always things have to be done. No, at no point we are going to make that claim, and no one should make that kind of claim. Okay, and then for historical data, you can segregate it and then you can basically train with the ML models. Now remember, model training pipeline is offline only, and schedules basically can vary on the criticality of application. Now for like Facebook and a lot of companies, they kind of train and retrain their model for every day. So every day they are changing their models to detect your faces, objects in the images and whatnot. Okay. For some people, it might not be required. It might be even a weekly update or a monthly update might be good enough. Now it depends. It depends that how much data are we playing around with, what is the criticality or what is the number of users we are dealing here with. The best idea is again to have a dedicated pipeline for each model so that all models basically run concurrently. And of course, the idea is to parallelize the training data. So if you can partition the data properly and if you build the models replica and for each partition, then the whole process can be run faster by utilizing large number of computers. And then of course, the classic reconfigurations of the hyperparameter model type, a selection of correct features and loss function in order to optimize is of course required. Now again, how do you evaluate your model? Anyone? How do we evaluate our model?
By checking it
Accuracy
on
is
the
curve.
testing.
Yeah, so you have various parameters, okay? Like you have ROC curve, PR curve, AUC curve, okay? You have metrics like accuracy, loss, accuracy, error, precision, recall, F1 score, right? So once you build the model and once you are cross-validating or testing, you should always test it against various predictors and just to understand which one is kind of giving the better performance so that you select the correct model. And then you deploy the model. Now, this is where after doing all this, after understanding so many things, then we come to the model deployment process. Okay. The best model is usually selected for offline or online prediction. Now, it depends on the system requirement. Of course, you can deploy multiple models at any time to safely transition between old and new models. Okay, because even when you are deploying the new model, the services needs to keep serving prediction requests. So what happens is usually in a distributed systems, it is done like in a distributed fashion. So the newer model is, let's say, updated on system one. Okay, so the traffic is taken away from system one for some time. So it is they use dynamic load balancers. So what they do is, let's say they have a distributed system. Any large scale company has a distributed system anyways. So let's say these systems, let's say system one, system two, and system three, basically are serving, let's say thousands of clients, okay? And let's say they are all running version 1.1 of the ML model, V1.1. Now what happens is, let's say I have to update with V1.2. So what does dynamic load balancer does is, it takes off the traffic and kind of shares them with these two systems. And when there is no utilization of system 3, then V1.1 is replaced with V1.2. Now all of this is just done in matter of seconds or sometimes milliseconds, okay? And then again the load balancer will start redirecting traffic back to system 3. Now system 3 is making predictions based on V1.2. Now the same replication will happen to system 2 and same replication will happen at system 1. A lot of this is taken care dynamically, so you don't need to understand how it will happen, but understand this model will be slowly replaced in each of the system without stopping any prediction.
Okay.
Now the problem is the production, Python is seldom used in production. Python or R are seldom used in programming language like production programming language. Means Java, C++, C Sharp are considered as the production programming languages. Okay. So the problem is if you directly try to port a model into Python or R, from Python or R into Java, C++ or C Sharp, it can actually lead to reduced performance of the original model. So what should we do here?
Some engine which will process Python and
Sorry.
directly deploy some engine which takes Python code and
Yeah.
run on the
So there
server
are
itself.
different issues. So a lot of people have these issues like how do I handle the code, because Python and R are not exactly always production level languages, right? So first of all, of course, there is the obvious thing that maybe you can rewrite the code in new language. But if I had that idea, why wouldn't I start already in C++ or C sharp, right? Why would I even bother with Python?
Yes.
You can also create a domain specific language to describe the model, although even that is very tricky. Not everyone has the correct team to even create a new DSL. Okay. Best is microservice. For a lot of people, microservice or API first approaches works the best. That you create a server over where Python environment is running, and everything can be communicated through REST APIs rather than deploying in the native language. Native language could be C, C++, Java, C Sharp, or some other languages which are used in production. You can create a microservice basically, or it is also known as API first approach basically. Or you can also use a containerization. How many people know about Docker?
Yeah. Docker or Kubernetes.
Yeah, so Docker or so Kubernetes is used to handle multiple Dockers basically at scale. Docker is just like an image, okay? So basically it creates an image and it can be put on different systems, okay? So if you have installed the Docker correctly, it will run the internal container as it is. So internal container could contain Python code, but it will be installed in each system now. And the system could be running natively Java, C++, C Sharp, anything. Okay. And what you could last but not the least, what you could do is you can serialize the model, and basically you convert it into a kind of a dictionary, serialize the model, and you can load it for like, okay, so when you load write a pickle file, actually pickle file can be read by C++. Okay, you can also open it in C++ and you can read the pickle file, but it is not possible for every model. Okay, because some models become incredibly complex, okay, after a while. So it is not always linear regression or logistic regression that we are trying to do. So that techniques doesn't always works. But yeah, sometimes with a smaller model, we can actually do this. We can save the trained model as a file, and we can open it with, let's say, C++. And over there, we can just write a custom program to make the prediction using those model values. Again, you can choose how to deploy. You can deploy in a container or run in a microservices. You can control. You can also write a wrapper. So like Kafka is in Java, right? But Kafka dash Python is nothing. It's just a wrapper in Python. Internals is running in Java anyways, but they have written a wrapper so that it can also run with Python. Okay. The best idea is to wrap your library into an API and let caller invoke it somewhere from remotely. Okay. And again, for scalability, it is better to create multiple parallel pipelines. Although if you use cloud services, they usually take care of the scalability problem. Okay. And of course, you will have to generate some kind of model scoring. Okay. So what is model scoring? Different kind of scores are utilized. Now, remember, a lot of model scoring is not about accuracy or prediction. It is about some business metrics. Like, is my click-through rate going up, or is it some kind of a numerical value, the output, or it could be prediction as a probability value as well. It could be name of the category or the cluster from which the new unit or new item is most similar. Okay. It could also be a list of recommended items. And then when you are doing model scoring, it could be like, is it increasing my business metric? Is my click-through rate per minute is actually increasing or not? Okay. Are we able to sell more things, or when we show something to some person, how fast they come to our website and buy that? Okay. So if our ML model is making correct predictions or giving correct recommendations, the idea is our business metric definitely needs to go up. And if that is happening, then our model is working in the correct direction. So remember, some business metrics could be very different from your conventional accuracy, precision, F1 score that you are using all the time. Now, trying to conclude this idea, basically try to understand this. There basically takes a village, means large number of people to work on whole data science life cycle. Anyone who tells you otherwise is basically lying or just plain ignorant person, or basically they might be using it as a negotiation tactic. basically understand a lot of people are involved here. Software engineers, backend developers, app developers, testers, data engineers, ML and DS engineers, DevOps, DBA, system admins. It takes different skills to build a complete software. Okay. You have to learn to how to work together in teams. No one person can solve it all successfully. I've been working in this field for some time, and believe me, even I can say that I do not understand all the modules. Okay, I do understand a lot of modules because of varied amount of work I have done in past years. But I also don't understand all the modules. I'm not a like I will not call myself a tester. I will not call myself a DevOps person, neither a system admin. Okay, I will just not app development I did like 6 years ago, and after that I have never touched it. Backend development I understand a bit. I can call myself a bit of software engineer. I can call maybe ML or DL engineer, but rest of the uh, kind of the names do not even stick with me. And even I have been working in this field for like what 4 years now. So that is the whole point, that one person will be able to solve it successfully. Even we are giving you the basics of various topics, it is not gonna be enough. At some point you will be dependent on different people. Okay. And remember, guys, just remember this point, because you just learned data science course, it doesn't automatically makes you good software engineers. Okay, it will take some practice and experience to become a good software engineer as well. And if you could merge the skills of software engineering with data science, then you truly can develop some really good applications for your enterprise or for your own purposes, which can really scale up, which are fault tolerant and which are easy to use, and it actually gives some value addition to your clients or the stakeholders. Now there again, there is no stoppage, or the list. The list is really very big here. Okay, so I'm not going to go in the whole thing anyways. Just giving you an idea, guys. Okay, there are a lot of resources which you can look forward to. So for backend frameworks, one can look into Flask and Django. These are Python based. Ruby on Rails, ROR, Node.js. ROR is on Ruby. Node.js, it is on JavaScript. Okay. For streaming, Kafka is one of the best, but you can also look into Apache streaming. Spark, Hadoop, okay, are pretty good for online data training and model creation, but they are better for distributed systems. When you have large scale distributed systems, you should go for either Apache Spark, Hadoop, or Scala. For app development for phones, if you want to do it, it is Android SDK or iOS SDK. Major cloud providers are Azure, Microsoft Azure, AWS. For containers, look into Docker. Microservices API protocol, if you want to learn, you should just definitely learn about REST protocol. For front-end design, there is there is a host of tools that are available, but few tools that I use is React.js and AngularJS. For NoSQL, MongoDB is the best. Like there is literally no competition from anyone else. For relational database, the list is pretty big. Oracle DB, IBM DB2, PostgreSQL, MySQL, MSQL Server. So you can choose, okay? You can totally choose which relational database you want to use. And if you want to use the data warehouse for cloud or for distributed systems along with Apache Spark or Hadoop, you can go with Apache Hive. Okay, it's pretty good, especially with Hadoop. It can process structured data in distributed systems. So again, this is just a very small list of softwares and tools that we use to develop various kinds of or to design various kind of system softwares or web-based softwares, okay, or application softwares as well. This is clear, guys?